Hello students, welcome back into the another session of CS22 operating system concepts using Linux and Unix. Up till now we have completed with 8 different units of this particular subject where it contains the basics of operating system and introduction of Ubuntu, installation of Ubuntu and some basic practicals that we can perform over the terminal windows. Lastly, we have done with unit number 8 that introduce the concept of Linux and says the difference between Unix and Linux. That is the part of chapter number 8, or we can say the unit number 8. Now we are going to start the next unit, that is unit number 9, called Linux booting. Into the Linux booting, mainly it contains 2 points, that is the Linux booting process, which demonstrates LILO, that is last in last out configuration, and GRUB configuration, and the second one is the difference between two user interface, that is GUI and CUI. So these are the two main part that we are going to discuss for unit number 9. So let's start with the same. First, we are going to discuss about Linux booting process. As we know that every operating system must have to pass through the first process, that is called as booting process. Here I am not just talking about the Linux or the Ubuntu operating system that we have already used for the practical purpose. Right now this discussion is in general for every operating system which we are using as a system software. So every operating system must pass through the initialization of the entire system, that is called as booting process. So what actually the booting process is? Booting process is a process which initializes the entire system, and it makes every hardware responsive whenever user accepts or whenever user pass any request to that particular hardware. That hardware must have to give the appropriate response. So that is called as booting process. What happen into the booting process? Just plug in the electric cord and press the start button. The process initiated is called as booting process. So what happen into the booting process? One common signal is passed to every hardware which is attached with the system. That hardware detect that particular signal and give response back to the central processing unit by giving the confirmation that I am ready to work anytime. That is the basics of booting process. If any of the hardware is failed to give the initiated response, system will display appropriate error message onto the screen that this particular hardware is unable to work due to XYZ condition. So that is the main purpose of booting process. Just observe one thing: whenever you are starting your computer, just press a power on button. One signal is passed to your keyboard. All three lights will blink together into the keyboard. Even you get a infrared light into the mouse. Even you get a blinking line into the CD DVD if you attach. Even you will get a continuous blinking light into the hard disk or central processing unit. Even the screen, a monitor screen which we are using as an output device, will get change its color from blank to green color. So that is the procedure which has been done by the booting process. This booting process will take a very less time to check the accessibility of the entire hardware which is attached with the system. Once every hardware is successfully enabled, or we can say once the hardware is successfully started, or we can say once the hardware is given an appropriate response, from the secondary storage device that is called as hard disk, the operating system, any of the operating system, either it might be a Windows or Linux, gets loaded into the computer. So whenever this booting process initiated into the Linux, some fundamental concept we need to keep in our mind as an being a learner of operating system concepts using Linux and Unix. So for that I have demonstrated all that concept in a pictorial representation which you can see onto the screen. So whenever the booting process occurs into the Linux, it considers these many components like BIOS, then MBR, then GRUB, then Kernel, then Init, and last one is run level. First, let's see the full form of every components. Here BIOS means basic input output system, MBR means master boot record, GRUB means Grand Unified Bootloader, kernel itself is a full form, Init means initialization, and run level which executes from XYZ directories. So all these components works together for executing the booting process into the Linux like operating system, and these components are common for all the different flavors of Linux like operating system. That means as far as this subject is concerned, we are using Ubuntu. So even Ubuntu, this many components work. Even there is another flavor called Red Hat, Kali Linux, Puppy Linux, XYZ. In all that types of Linux operating system, these components remains same. So one by one, it's time to clear every component. So let's discuss about BIOS first. Again, I would like to repeat the full form of BIOS, that is basic input output system. This BIOS system will check the integrity of other system resources. Computer, as we know that computer is made up of several input and output devices. Various input and output devices are attached with the system like keyboard, mouse, monitor, optional printer, CD, DVD, etc. etc. Many input output devices are attached with the system. So this BIOS will check the integrity of all the device with a computer, with a central processing unit or a central device. This integrity need to be checked because all that hardware should support the central processing unit for executing and responding to the user's request. So that is the main purpose of basic input output system. Now this basic input output system not only checks the integrity of all the hardwares, but it also search, load and executes bootloader program. If I am not forgetting, then booting process is initiated from the fixed memory of the system, that is called as read only memory. So whenever the computer system is made by the manufacturer, a one small program is installed into the system's read-only memory, which executes every time whenever you shut down and starts your machine for the general purpose. So, booting process initiated from the read-only memory. Next is, it took the bootloader into the CD-ROM, floppy disk, which is no more available into the market. It's very old. Again I am repeating, it took bootloader into the floppy disk, CD-ROM, pen drive, hard disk, and which you can select by pressing F5. During the regular days of our college, we have arranged a one workshop where we have teach you that how to install an operating system from the secondary removable secondary storage device called pen drive. Suppose you want to install an operating system by yourself into the system, you required this knowledge. First, we have to create a one bootable device where it contains a bootloader program. Just insert that particular pen drive into the USB port by pressing F12 from the keyboard. Select that particular secondary storage device from where the booting process get initiated. Once the booting process is initiated from the secondary storage device called USB, automatically it detects the setup file which you have already there into the pen drive, and you can start installing any of the operating system into the system. Either it might be a Windows or either it might be any flavor of Linux. So even it has been handled by basic input output system. Now once the bootloader program is detected and loaded into the memory, BIOS gives a control to it, as I have already told you that once the hardware which contains the bootloader program gets detected by the system, automatically the rights has been given for installing an operating system from that particular device. Now this is the functionality of BIOS. In computer system is made up of various many devices, various many sections. Once the work of specific section gets completed, automatically it get diverted into the another section. So once the functionality of BIOS gets completed, it transfers the control from BIOS to next component, that is called as master boot record, or you can say MBR. So over here I have written the full form of MBR, that is master boot record. It is located into the host sector of bootable disk. Typically one path is given called /dev/HDA. This is the default path of master boot record in Linux. But remember that MBR always stores into the first sector of bootable disk. Why we need to store this MBR into the first sector of bootable disk? Because every time whenever you performs the booting process, it need to be executed as the very first process from the entire system. That's why we have to store, or ultimately it gets stored into the first sector of bootable disk. The size of MBR is less than 512 bytes. So here I am talking about the space occupancy which has been taken by MBR for storing the necessary information. So MBR takes less than 512 bytes into the system for storing its information. Internally, MBR is divided into the three different parts. or three different components, where the first component of MBR is primary bootloader, second is the partition table, and third is validation for checking the MBR. All these three components have their specific size, where primary bootloader, that is component number 1, takes 446 bytes. Partition table takes 64 bytes and MBR takes 2 bytes. So all these three subcomponents works together for handling the process of master boot record. Obviously here we are getting confused that BIOS is clear. BIOS will check all the hardwares and integrity of all the hardwares, that whatever the hardwares get attached are running or not. It's very simple. But what is the purpose of MBR? So purpose of MBR is to load the booting process from read-only memory to the front end. So this is the main purpose of MBR. And as indicated over here, MBR is stored inside the first sector of bootable disk, which mainly consists of three different subsections like master boot record, partition table, and third one is the MBR validation of several size like 446, 64 bytes and 2 bytes. Now MBR actually contains the information of third component, which is called as GRUB, or we can say LILO in a older system. Now day by day technologies get changed into the market. The definition of technology is very simple. Technology means reduction into the size and improvement into the performance, which introduce the newer technology into the market. So into the old computer system, that means the computer system before 5 to 10 years ago, instead of GRUB, they are using last in, last out. So that component is nowadays replaced with a newer component which is called as GRUB. So MBR manage the third component as per the sequence number which we have seen into the first slide called GRUB. So in short, we can say that MBR loads and execute the GRUB bootloader into the Linux. That means MBR is over there to support and executes the information which stores inside the GRUB. So now it's time to have a look about that what is GRUB. So full form is very simple. GRUB means Grand Unified Bootloader. It means that suppose we have multiple kernel images get installed into the system, then this particular component selects which image is going to be executed. Again I am repeating my words. GRUB is a one type of identifier which identifies the several number of images which is installed into the single system, and as per the user selection from the list of kernel, which kernel need to get executed has been identified by the Grand Unified Bootloader. Let me make it simple. Suppose into the single computer system we can install dual operating system. Yes, it's possible. Again, let me revise the entire thing. Suppose we have a one computer system, and in a single computer system, suppose you want to install the Windows as well as Linux, then it is possible. Yes, we have to make a one sequence that first we have to install the Linux and then we can install the Windows. There is a one technical reason behind that. That's why I am giving you this idea. First install the Linux and then install the Windows. Now whenever once you install these two operating systems successfully into the system, and whenever you restart the system, then at that particular time over the screen there is a selection of an operating system. Option number 1 is for executing the Windows environment, and option number 2 is for executing the Ubuntu environment. If you select one and press enter, Windows get loaded over the screen, and if you select option number 2, Ubuntu get loaded onto the system. So that is handled by a grand unified bootloader. Whenever you come down to the college in a regular classes, if possible, just visit our new lab. In 30 PC, we have installed Windows as well as Linux. Just start that particular system. Whenever you start the system, you will get the two option onto the screen. That two option indicates that you want to execute Windows, or option number 2 gives an idea that whether you want to execute the Linux. So if you found that two option, then it has been handled by Grand Unified Bootloader. So third topic says that Grand Unified Bootloader displays a splash screen. Wait for few seconds. If you don't enter anything, it loads the default kernel image which has been specified into the GRUB configuration. Over here, whatever I have speaked becomes true. That means whenever you start the system which contains the two different operating system called Windows and Linux, and if you wait and you have not selected any option, then by default after few seconds automatically it loads the Linux, because the first operating system which we have installed is Linux, and into the GRUB configuration file automatically it gets set as a default operating system. Let's move on. So GRUB has the knowledge of file system. Older operating system, older Linux loads Lilo, which doesn't understand such type of file system. That means into the older operating system there is no an option of installing dual operating system into the single system. At time you can only install the single operating system in a computer, but nowadays into the latest computer system, as Lilo is replaced by GRUB, you can install dual operating system into the single computer itself. So what will be the location of GRUB? Suppose I want to see the GRUB configuration, then what will be the location? So the GRUB configuration file is stored inside the /boot/grub/grub.configuration files. Once the Linux operating system gets successfully installed into the system, browse through this particular directory, you will find grub.configuration, or directly you can search grub.configuration file into the system, and you can observe all these things is there into the particular file. Once the GRUB get installed successfully, before starting the discussion of kernel, here I would like to say one more thing. All these components, that is starting from BIOS, then MBR, then GRUB, takes a fraction of time to get their processes to be done. Very less time is going to be taken by BIOS process, MBR process and a GRUB process. By default, GRUB takes 30 seconds, or we can say by default GRUB gives a 30 seconds to the user for selecting a specific operating system. Let's move on. Next one is kernel. In a previous unit, we have discussed about the kernel in detail. Actually, kernel is a one type of special component available into the Linux-like operating system, which provides the communication bridge between the hardware and the several application softwares with the user interface. That means kernel is a intermediator component in between the user application and the hardware. That means it sends and receives every information from user as well as it receives the response from the particular hardware and sends to the user. That thing is mentioned over here. Kernel mounts the root file system as specified into the root directory in configuration GRUB configuration file. Kernel get executed from the directory called asbin/init program. Since it was the first program to be executed by the Linux kernel, the process ID of this component is 1. And this particular kernel get initiated from the random access memory, and it is identified as a init rd. So init rd is used by the kernel as a temporary root of the file until the kernel is booted and real root system is mounted. So kernel performs a very important task into the computer system for loading the operating system from secondary storage device to the front. It also contains necessary drivers, compiled file, and it helps access the hard drive partition and other hardwares. So kernel performs a very important task for loading the operating system from secondary storage device to the front. Next one is init. Init is actually a one type of table which contains a several set of information, where for a several set of information it contains a one digit. 0 is for hold, it holds the running process. 1 enables the single user mode. 2 enables the multi-user mode. 3 executes full multi-user mode, where every user can perform read, write and append and all the operation. That is option number 3. Option number 4 is for accessing the unused file. 5 is for X11. In unit number 1 we will discuss about X11 more in detail. And 6 is for rebooting the system. So all this sequence is maintained by init level. So whenever user selects a particular sequence, according to that it passes the digit into the central processing unit. Central processing unit identifies that particular digit, and as per that digit it executes the process ID, and that process ID will be there onto the screen. Next is run level program. These are the default program which get executed at the time of system's execution. Say for example, over the we can see the default running programs into the Windows operating system as I am using right now. You can see that whenever you start the taskbar, here I cannot start the taskbar because my recording gets stopped, sorry. So whenever you open the taskbar and just look at to the number of processes which is parallelly working at the time of executing the booting process, that is also possible into the Linux by using the last component of booting process that is called as run level programming. In run level programming, automatically taskbar sets the number of processes which is going to be parallelly executes whenever you start the operating system. Yes, over here you can see that these are the processes which gets automatically get started whenever I have started my computer system. That means I can see the date and time. There is an option of speaker, there is an option of network, there is an option of my default antivirus system which I have installed, so on, so on, so on. All these things are called as run level programs which executes during the normal booting process which has been handled by the system. In next lecture, we will see the older type of configuration which is used into the computer system, which nowadays replaced by the GRUB configuration, that is LILO configuration. That means we will discuss two sub topic about Linux booting process, that is LILO and GRUB configuration, in our next lecture. Thank you very much students for listening me, and have a nice day.